We have question number one. We have initial dose 0.25 milligrams and C0 or zero time concentration will be 0.05 milligrams per liter. And this is a straightforward question. What is the patient apparent volume of distribution? So question is asking about volume of distribution, and we have one equation for volume of distribution. It is a dose over plasma concentration. Do we have dose? Yes, it is 0.25 milligrams. Do not miss units. And we divided it on plasma concentration, 0.05 milligrams per liter. Cross in milligrams, and we'll have 5 liters. We'll have 5 liters. All right. Next question. Body mass. You see, do not miss this information. Always keep this information. We have 70 kg person, and we have dose equal to 2000 milligrams. You see, we have IV loading dose, and as we have IV infusion, we can say that bioavailability is 1. And peak plasma concentration or plasma concentration reported to 28.5 milligrams per liter. And the question is asking, what is the volume of distribution? Once again, we have volume of distribution. That is a dose divided on plasma concentration. In options A, B, C, D, E, we have liters per kg. That means that you should calculate volume of distribution in liters per kilogram of body weight. The question is that volume of distribution can be present or can be in the task in liters, or volume of distribution can be in liters per kilogram of body weight. And then if you would like to calculate volume of distribution for a specific person, you need to multiply this value on body weight. So let's calculate volume of distribution for our case. It will be dose 2000 milligrams over 28.5 milligrams per liter. That will be equal to 70.175 liters. But we have this answer, but check units. Units, you see, we got it in liters, and in answers, you have liters per kg. How to calculate liters per kg? We have person with 70 kilogram of body weight. So actually we can calculate the volume of distribution as a 70.175 liters divided on 70 kg. And this will be approximately 1 liter per kilogram of body weight. And this is the right answer. Next question. 150 milligram IV. Bioavailability is 1, and we have time 20 minutes after. The plasma concentration was 3 milligrams per liter. And assuming no elimination of the drug in these 20 minutes, so actually this corresponds to C0 concentration, what is the apparent volume of distribution? So once again, the straightforward question. Volume of distribution, and we can calculate it as a dose over plasma concentration, and this will be 150 milligrams divided on 3 milligrams per liter, and this will correspond to 50 liters, right? Because you're crossing milligrams and getting answer in liters. Next question. So we have IV dosage, yeah, and this dosage is 5 milligrams of kilogram of body weight. 70 kg. You see the chart at the bottom. Actually, we will use this chart because the question is asking which value comes closest to the apparent volume of distribution of this drug, and actually it asks about volume of distribution. Volume of distribution, it is a dose over plasma concentration. But look, we have dose not in milligrams, but in milligrams on kilogram of body weight, and we have person 70 kg weight. So first we should find dose that was infused to this individual, and the dose will be 5 milligrams per kilogram of body weight multiplied on 70 kg person. It will be 350 milligrams, right? So we have first number. But what about plasma concentration? Plasma concentration at 0 time, yeah, when elimination has not started yet. If you will have a look on this graph, you will see this line and dots, yeah, on the line representing the declining or decreasing in plasma concentration. But actually, you see they have started measuring of plasma concentration after around 1 hour after infusion, and we need to find at 0 time. So what we should do, we should extrapolate this chart, and we should prolong it, yeah, to the intersection with y-axis, and this intersection will be at the level of around 7. Have attention on the units, because we have micrograms per milliliter, not milligrams, but micrograms per milliliter. And actually this we can find this C0 from the chart, yeah, and it will be 7 micrograms per milliliter. 7 micrograms. 1 milligram, it is 1,000 of micrograms. So let's try to calculate. Look, we have 350 milligrams over 7 micrograms per milliliter. And here you should check units. Here we have milligrams, and in denominator we have micrograms. It is inappropriate. We can't do that. So we should convert either milligrams to micrograms or micrograms to milligrams. 7 micrograms, assuming that 1 milligram is a 1,000 micrograms, 7 micrograms will be 0.007 milligrams per milliliter. And now we can calculate. So it will be 350 milligrams over 0.207 milligrams per milliliter. Now you can cross milligrams, and this will be 50,000 milliliters. We do not have such answer, but we have 50 liters, and actually we can convert milliliters to liters, right? Because 1 liter, it is 1,000 milliliters. So divide on 1,000 and we will have 50 liters, and 50 liters, it is the right answer for this question. So here we have a little bit more things to do in order to calculate, and sometimes you will be asked to interpret graphs. And here you have found 0 time plasma concentration and actually calculated volume of distribution. Next question. So we have those 10 milligrams. First order elimination, IV, right? So bioavailability is 1, volume of distribution 80 liters. What will be volume of distribution if the dose, administered dose, will be 20 milligrams? volume of distribution, it is a dose over plasma concentration, but this doesn't help us. Volume of distribution, it is a constant for medication. Yeah? And if for the same individual, you will increase the dose, the plasma concentration will rise as well. This will keep the same volume of distribution, 80 liters. So if you are taking 200 milligrams of ibuprofen, you're getting one plasma concentration. And if you will take 600 milligrams of ibuprofen, you will have another plasma concentration. And it is obvious that second plasma concentration will be greater than the first one. The greater dose, the greater plasma concentration, but volume of distribution will be the same. So actually, in this situation, we will have a new level of steady state concentration because the dose will rise. And in this situation, steady state or plasma concentration will rise, but volume of distribution will be the same. In general, you should follow concept that if you increase in dose, plasma concentration rises as well. And as a result, volume of distribution remains at the same level. All right. So in this question, what we have? Clearance, 7 liters per hour. Half-life equal to 10 hours. And the question is asking, what is the volume of distribution? We can calculate volume of distribution as a dose over plasma concentration, but we do not have dose and we do not have plasma concentration. Let's refer to the half-life equation. It will be 0.7 volume of distribution over clearance. We found volume of distribution and we can use it for calculations. You can rearrange this equation. So let's do that. It will be half-life equal to 0.7 volume of distribution divided on the clearance. And now you can find 0.7 volume of distribution will be equal to half-life multiplied on clearance. And to find volume of distribution from that, you need to divide the right part of equation, right? So it will be half-life multiplied on clearance and divided on 0.7. So what is the answer? 100, right? That will be 100. Clearance 7 liters per hour multiplied on 10 hours and divided on 0.7. Hours we're crossing, getting 70 over 0.7 liters, and this corresponds to the 100 liters. And the last question related to the volume of distribution. Okay, so we have plasma volume and blood volume. Yeah, so we have plasma volume equal to 4 liters and the blood 8 liters. After that, we have concentration of the medication. And we know that concentration in extravascular compartment 100 times higher than concentration in the vascular compartment. If we will assume that X, it is a concentration or amount of the medication in the plasma, then here we will have 100x, 100 times higher. Let's have a look on volume of distribution. It is a dose divided on plasma concentration. And dose, actually, it is amount in the body, total amount in the body. And concentration, it is something as amount over volume. Could we find amount of the medication in the body? Here we will have 100 times greater, and here we have X. The total amount will be 101X. And here we have plasma concentration. plasma concentration, that is amount per volume. Amount of drug in the plasma, we say it X, and plasma volume, it is a 4 liters. So plasma concentration, it is X over 4 liters. Could we calculate? Volume of distribution will be equal to the dose, it is a 101x divided on X over 4 liters. And this will correspond, so we're crossing this X like a 101 multiplied on 4 liters and will correspond to the 404 liters. Loading dose.